Hi there guys, welcome to this video on histograms. Now, we're going to just add a little bit extra to the GCSE that you're used to, and that's this little bit here in blue, and we're going to deal with that in a minute, but it's just a very standard line of text that you're going to see. But first things first, we need to get confident again with histograms from the GCSE. So you can expect to see a one variable table. So here we have t as our variable, don't know what it is, not told any information, so let's just pretend it's time. Okay, so we've got 12 to 14 minutes, 14 to 16 minutes, and we have the frequency column in here. So whenever you see the words histogram, you should be thinking, I need to find the frequency density. And if you remember, that was the class width divided by the frequency. I'm just going to pop that formula up there for us. Okay, so let's do that. So we've got 4 divided by the width of the first group, which is 2. 4 divided by 2, nice and simple, is 2. 8 divided by 2, that's 4. 12 divided by 4 is 3. The next group is still a 4 class width, so 16 divided by 4 is 4. Now here the width has changed once again, so it's now 6, and 3 divided by 6 is a half. So if you remember with histograms, it's not a bar chart. We can change the widths, and we do that just so because we can, and it's going to always look nice, so there won't be any gaps between the bars. And then what we asked you to do at GCSE, very simply, is to plot it. So we had a frequency density column, and we had our variable along here, which is in this case t. Now, we're not going to ask you to do that anymore, because we're going to give you this standard bit of text. So if we were going to draw this, if we're going to draw the 16 to 20, so here we'd have a scale, so like 12 for example, 14, and then 16, and I'm just going to skip a few here, so 18 and there's 20. We would normally draw this from 16 to 20, and we draw it up to 3. So it would look something like this, and this value here would be 3. But they're telling us something pretty strange here. They're actually going to draw it with a width of 2, not 4, and a height of 9. So what I like to do, just going to remove all of this quick, is instead of drawing it on a graph like that, I just draw the rectangles, just draw the bars. So for 16 to 20, normally I would have drawn that with a width of 4 and up to 3 on the frequency density column. But they're telling me that they want to draw it with a width of 2 and a height of 9. And all you have to do in this question is just to work out what on earth is going on here. What scale are they applying to this because they can? So let's just compare the widths. What's happening here? You should be able to see it's being halved. Now don't look at that and think, oh, 2 has been taken off, because then it's not like a scale. Like I think of your length scale factors from easier questions in the GCSE. So we're always looking for a multiple, or this is a multiple of a half, for example, but divided by 2. Let's do the same thing with the widths. We can see here they are being times by 3. So we're going to take this information and translate it to the other class widths in the question. So let's look at this first black one here. We are looking to draw this bar, so normally we would draw that with a width of 2, and for 12 to 14 it would be up to 2 on our frequency density. But what are we going to do now? So using this scale, we're going to divide the width by 2, so it's now going to be 1, and we're going to multiply the heights by 3, which is now 6. So the 12 to 14 group would be drawn with a width of 1 and up to 3. Let's look at the second bit, so 24 to 30. You can see there's a width of 6, and the height would be up to 0.5. That's what we would normally do before this video. But now, because we've got this style of question, this scaling up question, the width is now going to be divided by 2, and the height is going to be times by 3, so we get 1.5. And it is really and honestly as simple as that. Let's look at a slightly different question. So for this one, we don't have the inequalities in the groups. We have this. Now there'll always be some information at the start saying, this data has been recorded and rounded to the nearest minute, for example, or gram, whatever it is this x variable is representing. So what that means is there are values bigger than 14 and less than 15 that exist, but because they've been rounded to the nearest whole number, they've been assigned to one of those two groups. So we're going to have a look at bands to compensate for that. And we did that in interpolation, so it shouldn't be anything new to you. So go down to 11.5 and up to 14.5, which means the class width is now actually 3, when at first glance you may have thought it was 2. The same for this one. It's going to be, it's not going to be that. We're going to go down a half. So the lower bound of 15 and the upper bound of 16 is 16.5. So this group looks like it's a 1, but the class width is actually 2. So let's form the frequency density column. So the width of this one is 3, so 6 divided by 3 is 2. The width of this one looks like a 1, but you can see from the bounds it's a 2, so 8 divided by 2 is 4. This looks like a 1, but the width is actually 2 because of the bounds, so 12 divided by 2 is 6. This appears to be a 3, but with the bounds it's a 4, so 4 divided by 4 is 1. Okay, so let's look at this standard bit of information. So 15 to 16. So what would I normally do for 15 to 16? I would draw that with a width of 2 and up to 4. But what are they wanting me to do? A width of 3 and a height of 8. So all we have to do is work out what's going on. And you should hopefully agree this is timesing by 1.5, and this height is timesing by 2. So let's have a go at these questions. We'll call this one A and this one B. So we'll do A. We're going to try and squeeze it in here so I don't have to scroll up and down. So A, 17 to 18, looks like a 1, but with the bounds it's a 2, the width I'm talking about there. And for 17 to 18 group, I would normally go up to 6. But with this extra information, they want me to draw it with a width of 3, 1.5 times bigger. Actually, it's the same as the example. And the heights we're going to times by 2. So 6 times 2 is 12. Part B. So that's a width of 3, height of 12 for that one. So part B, 19 to 22. I would normally draw that with a width of 4 because of the bounds. And we can see from our table up to 1. The width is now going to be 1.5 times bigger, so it's 6. And the height is going to be twice the size, so it's going to be 2. A width of 6 and a height of 2. Now it really is that simple. So have a go, but you shouldn't really run into too many problems with these. So this won't be an entire question in an exam. This would be like one part, very simple, and you just, they're 3 marks basically. Right, best of luck everyone. Good luck.